Welcome. This video will contain the last three problems from the first half of section 5.2. Again, there's an awful lot going on in chapter 5, and we really have to have a keen attention to detail on this. But this is kind of continuing the guts of what we were just doing. Once again, it's a new section, but the directions are the same. Find the local extrema, the intervals which the function is increasing, and the intervals on which the function is decreasing. When I'm asked multiple things, I'm going to plead with you, please off to the side. Too easy to skip a part. Please off to the side, write down a spot for what you're actually looking for, because we do have three sets of directions here. So the first thing we want to do, we want to consider, do we have any endpoints to find extremas? Well, I can take the third root of anything I want. I can add 8 to anything I want, and I can multiply anything I want. So we don't have a defined interval. We may even want to think of this function as x to the 4/3 plus 8x to the 1/3, and kind of put it in polynomial form, not a polynomial, but kind of put it in polynomial form. And that way we can say, well, what happens as x gets huge? Well, as x gets huge, our end model behavior, as x gets huge, this graph is going to get huge. It's going to rise, you know, if this is more than x to the first, so it's going to be bigger. If I put in 10, I'm going to get more than 10 and more than that. It's going to get bigger and bigger and bigger. As I put in a big negative, this term will actually become positive. Or take a look. If I put in a big negative here, I get a negative times a negative. Negative to the 1/3 is a negative times another negative. So I'm going to get positives to the right as well. This is going to want to rise to forever to the right. Okay, but no endpoints. I expect we have no extreme maximums, but we might have some local maximums along the way. So let's get to it. F prime of x. If I use this, and you could product rule this if you wanted to, I'm going to use this. I get 4/3 x to the 1/3 plus 8/3 x to the negative 2/3, and I want to get common denominators on this, and you might say that's 3, but not quite yet. This is 4x to the 1/3 on 3 plus 8 on 3x to the 2/3. Therefore, my least common denominator, I need a factor of 3, but I need a factor of x to the 2/3 as well. I had to multiply this by x to the 2/3 on x to the 2/3. We can do that. In fact, it's kind of nice. I get 4x to the first, and that would be on 3x to the 2/3, just plus 8. So now I need, where is my slope 0? Slope is 0 when the numerator's 0 or when x equals -2. So f of -2 is of interest to me. I get the third root of -2 times -2 plus 8 times 6, or -6 third root of 2. That's where the slope is 0, and it's not just where the slope is 0, it's the only place the slope is 0. Now, how about points of non-differentiability? Points of non-differentiability occur when the denominator is 0. I'm taking a third root, so it's okay to have x be a negative value. In fact, if x was a negative value, that gets straightened out when we square it anyway. So points of non-differentiability are x equals 0. Weird things happen in the graph. There's a really good chance that this graph has some leveling off, or excuse me, might be coming close to infinity at x equals 0. For instance, if I put in 0, I get 8 on 3 times 0, I get 8 over 0. That tends to be drawing toward infinity. Not necessarily the curve, but the slope is becoming infinite. Okay, so let's go to our sign value here, sign of the derivatives. So this is f primes signs. We know at -2 it is 0, and we know at 0 it's interesting. It's undefined here. Let's see what happens around those values. If I put in, say, -1 here, if I put in -1, my numerator will become positive, my denominator will be positive, and I will have a positive derivative or a positive slope. The graph's going up there. If I put in a value to the left of -2, like -3, my numerator becomes negative, my denominator is positive because the -3 gets squared, so I have a negative, making -2 a local minimum, at least a local minimum. Maybe it's the entire minimum. Okay, and then at 0 I got problems. I can't put 0 in. And then after 0, if I put a number bigger than 0, like 1, I get positive on positive again. So it's going up and then going up again. So if I believe all of this, I have a minimum of -6 third root of 2 at x equals -2, and the graph is going up, and then after this it's going up again. I suspect maybe our curve it goes up at that value and it comes down here and comes up again, but that doesn't indicate that we have a maximum at 0. In fact, 0 is non-differentiable. So I believe we have this minimum, but we do have increasing graph from -2 to 0, and we have in union with it increases on the other side of 0 to infinity, and it decreases from -infinity until -2. Invaluable for us here, analyzing the signs of the slopes. Okay, how about this one? I know that x cannot be plus or minus 2. So those are going to be interesting points for us where things could change. That will probably show up in our non-differentiables as well. So I don't have endpoints. As x gets huge, big X test tells us we're going to approach 0. Huge value over much, much, much huger values. So we're going to approach 0 on the ends if that's of use to us later. We may think of that as, well, what's our graph do? It ends up being very close to 0 as we move on. That's just a study of limits, or what I'm referring to as big X test. All right, k prime x, k's derivative, low, x squared minus 4, d high is 1, minus high, d low is 2x, over square of the thing below. Okay, so let's get some simplifying here. Equals, I'm going to get an x squared minus 2x squared. That's a negative x squared. I'm going to get a minus 4 all on x squared minus 4 squared. And I want to know, when is the slope 0? The slope is 0 when negative x squared minus 4 equals 0, or when x squared equals negative 4, but that can't happen. This graph never levels off. When are we non-differentiable? We're non-differentiable when x squared minus 4 squared equals 0, and, whoops, just that part, sorry, not a fraction. When x squared minus 4 squared equals 0, or when x equals plus or minus 2, but x equals plus or minus 2 doesn't exist. So what the points of interest for us now to look at our slope signs would be around 2 and -2. Doesn't exist. Let's see what happens between there with our slopes. If I put in 0, I ultimately get a negative on ultimately a positive. Negative on positive, it's going down from -2 to 2. If I put in 3, I ultimately get a negative in the numerator. I ultimately get a positive in the denominator. It's negative. If I put in -3, I ultimately get a negative in the numerator. I ultimately get a positive in the denominator. It's going down at all of those intervals. How could that possibly be? Well, I suspect we have at 2 and -2, asymptotes. I know we're getting close to 0, so I could have it going down here. It could go down up in here, and it could perhaps go down through there. I guess it can go down all the time, but we can't say from negative infinity to infinity because it's not going down where it doesn't exist. So it's decreasing from negative infinity to negative 2 in union with negative 2 to 2 in union with 2 to infinity. It's increasing never. Extreme is none. And just too tempting to check that on the calculator. Could that possibly be correct? Let's go to y equals, clear this, x on all of x squared minus 4. I don't want to be on the same zoom fit. I'm just going to go zoom standard here. Zoom standard 6. There's down, down, and down. So everything we thought was confirmed there with this little chart right here. The graph is going down, it's going down again, it's going down again. Okay, let's see, we got one more problem to look at from this A portion. Throwing some trigonometry at us here. 2x continuous forever, cosine of x continuous forever. What happens is we put in big X's. Well, I know cosine is going to go between negative 1 and 1, but when I put in a billion, I get 2 billion between something between negative 1 and 1. It's going to go up forever. When I put in negative a billion, I get negative 2 billion between something between 1 and negative 1. It's going to go down forever. We have no max mins. But we got some bumps going on here, so this one could be interesting. G prime of x equals first derivative 2 plus cosine's derivative negative sine of x. So we get 2 minus sine of x. That is our slope formula. So we need to go ahead and check when is that equal to 0. Well, it's equal to 0 when 2 minus sine of x equals 0, or when sine of x equals 2. When does sine of x ever equal 2? Never. When is sine of x, when is 2 minus sine of x undefined? When is this thing non-differentiable? That's 2 words. Non-differentiable, well, would be anything that would cause a problem for sine, but we can take sine of any angle measure we want, and we can subtract any number we want from 2. Never. So extremes. It never levels off. It's never non-diff. None. Increasing. Okay, now we got to take a look at this guy. Let's take a look at G prime. Well, we've kind of solved this already, but there are no real interesting points here where this thing levels off, and any value I put in for sine, the biggest it's going to be is 1. 2 minus 1 is positive. The smallest sine is going to be is negative 1. 2 minus negative 1 is positive. It's always going to be positive. Therefore, it is increasing from negative infinity to infinity, and it is never decreasing. Wow, we thought this was going to be a challenging one for us. Let's take a look at the graph. I suspect it's going up sort of along the line 2x, but it's got to be doing some wiggling as it goes. That might be an interesting graph. Let's go y equals, does it matter? I'm going to go mode radians. Let's make sure we're in radians here. Sure enough. Y equals, clear this guy. Kind of a cool looking graph, I suspect. 2x plus cosine x. I think zoom standard may be good for starters, but cosine x. Graph that guy. And reason to believe, let's go window. I'm going to go negative 100. Maybe I'll regret this. Haven't played with this one yet. To 100, and I'm going to zoom 0, zoom fit this guy. Reason to believe that might continue forever. We don't even really see the wiggling much now. I mean, maybe just barely we can kind of tell it's in there, but just going to go up forever but never level off. And sure enough, calculus was good to us here. So Hope that helps, and stay tuned. We'll be doing quite a few problems in 5.2.